Go.
So today we're talking about solving quadratic equations. I figured you guys might benefit from me making a video to show you a few examples rather than just watching one from online. So these are going to be very similar to when we were factoring quadratics. This is the next step past that. We're going to be solving equations now, so we're solving for x. We're solving for the variable, okay, but now we're in different forms than we've seen before, okay? So if you look at this one here, example number 1, all right, we have two factors here. This is a factored form of a quadratic, okay, and we have these two things equal to 0. So x plus 8 times x minus 2 is equal to 0. So what you want to focus on is the fact that whenever we have something is equal to 0, any product, when you're multiplying two things, two terms, and they're equaling to 0, what has to be true is that one of those two things has to be equal to 0 in order to get 0, right? One thing times 0 is equal to 0. So we have to figure out what numbers will make either one of these equal to 0. So the way that we do that is we take each factor here and we set it equal to 0. So we start with x plus 8 is equal to 0, and x minus 2 is equal to 0. We then solve each one of those to get our values for x. So in this one we would minus 8 from both sides, giving us x is equal to negative 8. Here we're going to add 2 to both sides to give us x is equal to 2. So our final answer, x is equal to negative 8 or 2. Either one of those, because if you think about it, if we were to plug either one of those numbers back into the equation, we would get 0 as an answer. Negative 8. Negative 8 plus 8 is 0. Negative 8 minus 2 is negative 10. 0 times negative 10 is 0. If we were to plug the 2 in, 2 plus 8 is 10. 2 minus 2 is 0. 10 times 0 is 0. So pretty much all we want to do when we're in factored form, again this is factored form because we're looking at two factors, okay? When we're in factored form, all we got to do is set each factor, each one specifically, equal to 0. Solve for each x individually, and that's how we get our final answer. Let's take that concept and work on number 2. Same idea. And if you want, after that first example, if you want to pause it and try to solve this one before I do, feel free. Okay? So, hopefully you've tried this one already. So, same idea, right? We have two factors. Just because there's a number in front of x doesn't change anything. We still have two factors here, and we're going to set each one equal to 0 to see what the x values could possibly be. So we have 2x minus 9 is equal to 0. And we have 3x plus 4 is equal to 0. Okay? Same idea as before, we're going to solve for x. So in this case, we're going to add 9 to both sides, giving us 2x is equal to 9. Then we're going to divide by 2 to both sides, giving us that x is equal to 9 over 2. On this side, we're subtracting 4 from both sides, giving us 3x is equal to negative 4. Then we're dividing by 3 to both sides, giving us x is equal to negative 4 over 3. So our two possible answers are 9 over 2 or negative 4 over 3. So again, that is when an equation is in what's called factored form. This is for a quadratic. You see two factors, and I know we just went over factoring quadratics the last 2 days, okay? In example number 3, a little bit different, okay? Now you notice we have one factor in parentheses here, but then you have this number on the outside. But the one thing to remember is this is still all multiplication. Anytime you have a bunch of different terms written next to each other without any other signs, it means multiplication. So we have negative 5 times n times 2x minus 3. So we still have a situation where different numbers are being multiplied together to give you 0. So one of those two things has to be 0. Sorry, this should be an x. Okay? So one of those x's has to be something that makes either one of those 0. So what we're going to do, same idea as the first two, I'm going to write my term on the outside, this negative 5x, that's going to be one factor, is equal to 0. And then 2x minus 3 is another factor equal to 0. So if we're solving here, well, this one's only one step. We're just going to divide by negative 5 And what's 0 divided by anything? You guys see me drop my cap? And what's 0 divided by anything? 0. So 0 is one of the possible solutions to this. Now when we solve this one, 2x minus 3, same thing as before. We're going to add 3 to both sides. Give us 2x is equal to 3. And then divide by 2. So our x is either going to be equal to 0 or 3 over 2. Lastly, okay, you see an example here, and our example is in standard quadratic form, right? We have an actual quadratic here. So in order to solve for this one, we're not going to solve with an x squared and an x here. That's impossible. So what we're going to do is we're going to turn this standard form of a quadratic into factored form. So we want to factor this quadratic to get it to look like something like this, something like this, or something like this, since you know how to solve those already. So now we want to try to factor this and solve it that way. If you want to pause it here and try to do it on your own, feel free. Okay? So the first thing we want to do is factor. And you know the way we went over factoring, we know our factored quadratic is going to be 2 sets of parentheses. And we're going to use our rules to try to figure out what's going to go inside those parentheses. Okay? If you remember, we looked at this plus sign here, and that plus sign told us that these two signs in the middle were going to be the same. So this minus sign tells us they're both going to be negative. So we can go ahead and put our minus signs in the middle there. Okay? Remember, this x squared tells us that these first two terms have to multiply to give us x squared. And as far as I know, x times x is the only thing that we can use to get x squared. So now lastly, for these two, we need something that's going to multiply to 30 and add to negative 11. So we need two numbers to multiply to positive 30 but add to negative 11. Remember, we know they're both going to be negative, so we know whatever two numbers we pick, they're going to both be negative. So what are our possible multiples of 30? We have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Out of these pairings, which is the only pair that adds up to 11? 5 and 6. Now once we've done that, we're not finished. Now we can actually solve it like we did in example number 1. Again, if you want to pause it and try from here, I suggest you do so. So to check your work, we want to go here now and solve each one. So we're going to set each one equal to 0. Just like we did in the first example, we're going to solve for x. Add 5 to both sides. We get x is equal to 5. Add 6 to both sides. X is equal to 6. So x is equal to either 5 or 6. Now, I know that's a lot. I got 2 more examples I'm going to do. These are 2 more examples you might see on the assignment that we're doing today. So let me erase this real quick. Again, if at any point you got confused, you can always go back and redo a problem. You can pause it. You can screenshot the board once it's all filled up. You can use that as notes. Copy those notes into your notebooks. Okay. So last 2 examples. We have an example that looks like this. 3x minus 2 squared equals 0. Right? When we have something that looks like this, what does this mean? All right? When we have something squared, remember, that squared means that we have that factor twice. It's this times this. So it's 3x minus 2 times 3x minus 2 is equal to 0. Okay? Obviously, then we're going to solve this the same way we did prior. So we're going to have 3x minus 2 equals 0. 3x minus 2 equals 0. You can probably figure, since these are the same thing, we're going to have the same answer. So when we add 2 to both sides, we have 3x equals 2. Divide by 3. X is going to be equal to 2/3. Since they're the same problem, we're only going to have the one solution there. Okay? Again, you can pause that and make sure you write it down in your notebook. The last example. Now remember, we went over standard form of a quadratic was ax squared plus bx plus c. So if it's not, so we need, in order to factor the quadratic, we need it to be in this form. So if the quadratic is not in that form, we need to put it in that form first. For example, 2x squared. Minus 9x. Okay, 2x squared minus 9x equals 5. In order to solve something like this, we need to set it into standard form, okay? And then we're going to set the standard form of the quadratic equal to 0. So the first thing we want to do is make this look something like this. So since we have this 5 on the other side of the equal sign, we're going to bring that over to the left. So we're going to subtract 5 from both sides first. Okay, in doing so, we end up with 2x squared minus 9x minus 5 is equal to 0, seeing as 5 minus 5 is equal to 0. Now we want to factor, okay? And if you remember, we went over specific ways to factor an equation when a, okay, the number in front of the x, wasn't equal to 1, all right? And if you remember, we did this method here. We took a and we multiplied it by c. We multiplied by c. So 2 times negative 5. Remember, that became that number on the right-hand side. Okay, so we had x squared minus 9x minus 10. 2 times negative 5 is negative 10. From here, this is when we factored. Okay, now we're going to factor just like we did the quadratic earlier, like in number 4. So we're going to factor just like we did. Here's our 2 factors here. Okay, we know we're going to have x and x here. These minus signs, remember this minus sign means both signs are different. This one just means the larger of the two is going to be the negative one. But I know I'm going to have one positive and one negative. And what are my factors of 10? Excuse me. What numbers times 10 are going to add to give us 9, right? Or subtract to give us 9 since we're dealing with negatives here. Well, we're going to have, it's going to be a negative 10 and a positive 1. 1 times negative 10 is negative 10. Negative 10, positive 1 is negative 9. Now that I have these two factors here, okay, if you remember, since we borrowed this 2 from earlier on, okay, we actually have to go ahead and make sure we put that back in the front of each factor. So I'm going to go ahead and stick that 2 back in here, okay? And since we only borrowed that 1 2 when we multiplied, but we gave 2 2's back, we then have to simplify by one total number 2, okay? In this case, we're going to look at each factor and pull out a common factor, a GCF, if either of the factors have one. And in this case, notice the 2x and the minus 10, there's a GCF of 2, which is the number we need to remove. So we're going to divide that whole thing by 2 to give us our final factored form. 2x plus 1, x minus 5, and then solve them just like we did earlier on. Okay? I'll let you refer back to the earlier steps for the work. Our final answer here is going to be x is equal to negative 1/2 or positive 5. Just a few announcements while you guys are listening to this. Make sure you are sending me those 10 worksheets that you previously downloaded while we were in school. Make sure you send those to me as soon as you can via email or Remind. Make sure you are completing these assignments on a timely basis. Understand that although they are assigned for this week, I will allow everything to be due the following Monday, and that's going to be the same going forward. All the assignments that we work on, I will upload almost all of them the beginning of the week so you can work at them at your own pace. Understand, though, that they will all be officially due the following Monday. And grades are as they normally are. Classwork grades are graded like they were with check pluses, checks, and all that. And the quiz grades will be graded numerically with the score that you receive. If you have any questions, email me or message me. Stay safe, everybody. I hope this helped.